Alright guys, so welcome to today's video. And in today's video, we want to continue with this OP move right here from the last video. So I hope that you guys have seen it. I hope that you guys understood it. And yeah, so for those of you who do not know what I'm talking about here. So we're now able to cut those objects right here. And in today's episode, I would like to make those objects movable. Means when you point somewhere, those objects will be moved towards that position, and then that will cause damage, of course. Okay, that's the first thing I want to do. And secondly, I would like to tweak some stuff because there's still a lot to improve with this model right here. Okay, so let's get started. All right, let's go inside of this script right here. Okay, and the first thing we want to do is that we down here, that we create a folder, cut parts folder. Okay, this folder right here is going to contain all of the cut parts. And you might ask why, because currently when we want to refer to all of the cut parts, then they are just randomly inside of the workspace, you know. And when we play and when we try to refer to them outside of this function, then we will run into difficulties. Because let me just quickly do this. So as you can see, we already have a bunch of parts right here. So the first challenge is to keep them apart. But apart from that, you don't have to keep those apart, those apart, those apart, you know. So there's just a bunch of unions right here, and we have to put them inside of a folder in order to tell, or to exactly tell, yeah, so those are the unions of the cut part, you know. And why do we need that? Because later on, when we are supposed to make those cut parts move, then we can just easily loop through that folder, and by looping through, we can just, you know, make them move, probably via body position. So I'm probably going to use that. And yeah, so just make sure that the name of this cut parts folder is, yeah, something unique. And I really think about putting this inside of the character, actually. But let's not do that. Let's add the player's name to this folder's name. So cut parts folder and then player.name. So we combine this string, which is constant, so cut parts folder always stays the same, but the player name actually changes, and those two dots, they connect the player's name and this constant cut parts folder string to each other. And to put those cut parts inside of there, all you gotta do is that down here can actually say cut part parent workspace, not find first child, but let's use wait for child, cut parts folder, then two dots, and then the player's name, player.name. And now repeat the same step for the second cut part 2. And let's take a look at this. So let's see how this works out now. So as you can see, we have this folder and this works. So all of the unions right here, or everything which is inside of this folder, belongs to this folder right here, you know. Wait, the problem is, so there are some instances, yeah, like those, for example. I don't know why they're still inside, but well, okay, so look, so this, for example, is being destroyed. I think that the problem is that I'm just clicking too fast, yeah. Okay, yeah. That is actually the problem, so... yeah, so... yeah, okay. I'm clicking too fast. So in order to get rid of all of these additional parts, we can do the following. So we can loop through this folder. Yeah, let's call this I99 and V99 because I think that we have already used I and V too much. Yeah, for example, right here. And I just want those variables right here to be different. Okay, then refer to this folder as I've told you, and then do get children to get all of the children inside of there, so all of the instances. And now we have to think about what the difference between those additional parts, which we want to get rid of, and our actual cut parts are. And the difference is actually pretty obvious. So, of course, the cut parts are visible to us, and the additional parts are not visible to us. So we were only able to see them by, you know, clicking on that folder and seeing all of the instances because it was highlighted. So as you can see, those are highlighted. So they have this blue, and yeah, this blue, no, those blue lines right here. But as you can see, they are now, yeah, instances which are highlighted as well, but which are invisible. Means they are like useless to us because you cannot sense them without clicking on the folder and having things highlighted right here. And the difference now is that those are transparent while others are visible to us. You know? So we want to loop through this folder and we want to check which instance has transparency 1. So we are looping through and we are checking if the instance we're currently at has transparency 1. And if that's the case, then we want to destroy it. Okay. And that's it. Okay, I hope that the issue right here is now being was now fixed because of that. As you can see, so I'm not able to cut as I want to. Okay, there we go. So there are no additional instances whatsoever. So everything is fine right here. Okay. So one more thing I want to deal with is that, so as you can see, when we cut apart, they levitate, okay? So they levitate, and maybe not in this case, but in some cases, for example, I could try to provoke it right here. Wait. Okay, wait. Yeah, no. Wait. Look, so what I'm trying to point out is that the problem with this levitation right here is that those parts, when our range would be great enough, we could just cut them till they reach out of the room, you know? And that's a problem. So they are too high. And we want to, yeah, take care of this levitation right here. As you can see, or as you know, those body positions are responsible for making those parts right here levitate. So we want to take care of this position, of those position values right here, in order to prevent that those cut parts are moving outside of the room. So how can we do that? We have to work with those sizes. At least I would recommend doing that. So yeah, let's do this then. So come on. So wait, so why is this taking cut part 2's position? That's the first question. Yeah, so cut part position divided by math random 2 to 4. And let's do the same thing down here. So we are using our cut parts position, yeah, right here, and we are additionally adding our cut parts position divided by a random number. So it is important that you do not use any random numbers and then just additionally add them onto your current position, it is important that you have, while adding something additional to your current position, that this additional thing right here has an influence, or an influence of any of your of your object, let's say. So could be size, could also be the position. I'm gonna use the position now. Wait, no. Let's actually use the size. And the randomized thing about this additional value, about this addition right here, is that we are using this math random right here, okay? So it is important that you have any component, when it comes to additionally adding onto something, any component which has a relation to your object right here. Otherwise, you will have one certain problem, and I've already tried to point out that problem in our episode, in our previous episode. And that problem is that your position does not really adapt to the object right here, no? Right, yeah. Look, so they only move in one direction, right? Then let's have it like this. So how about we do -4 to 4, and let's see how this will work out then. There we go. Perfect. Wait. No, they have actually moved down. Come on. No. Wait, why do we have several parts right here now? Wait. This does not even make sense. Oh yeah, wait. It is because, oh my god. Look, the reason why those parts disappear is because it tries to divide through 0. That is the problem. Interesting, yeah, really interesting. Then let's use 1 to 4, and right here we use -4 to -1. So we have one part which goes in one direction and the other part goes in another direction. So we have so we have this variety right here. Look, so the problem is still that it is moving too much. So let's really use different numbers then. Instead of 1 to 4, we're going to use 4 to 10. Because the more you increase the random values right there, the less it will move, you know, because that's just how the math works. Okay. Yeah, as you can see, it is now moving less. It also depends on how big your room is, okay? So if you have a big room, then you also have, big room to make those objects right here levitate into. Okay, yeah, but this is fine, okay. So we have this folder right here. Now the next thing I would like to do is is actually quite simple. So of course, when we have this right here, or when we speak of using this model instead of a real One Piece game, then this move right here will obviously be too OP, because you're able to cut through anything, you know. So you could, well, anything which is a part or a union. So if you have a map which only consists of parts or unions, then you would have the problem that, for example, the map space, you know, so the island itself, that you're able to cut it through as well. And I think that there are parts which shouldn't be cuttable. For example, an island or the island's ground, okay? So this one huge block right here, which actually forms the base of the island. So if you cut that through, then you have a little problem, okay? So we're now going to add exceptions to your cut move right here. So let me create a part which should be resistant. So means you shouldn't be able to cut through this one. So how would we do that? It's actually pretty easy. So you just have to add an instance inside of here. Let's use an int value. And let's call this one not cuttable, okay? So once you have this int value inside of the part or the union you do not want to be able to be cut, then we are going to add a check right here, which verifies whether the part you're trying to cut through does not have this instance inside of there. And if that is the case, then you can just easily cut, okay? But if the instance is inside of there, then you're not able to cut through. So we have some checks right here. And as you can see, yeah, first requirement, either your instance is a part or a union operation. Second check is about the distance, and we can already combine, or we can add this check I was talking about as well. So if not be find first child not cuttable. So if the distance is alright, and if there is no instance inside of this instance called not cuttable, then you want to continue, okay? Now, let's check this out. Let's see if we are able to cut through this object right here. As you can see, we are not, so there is no click detector inside of there. That's the reason why we are not able to cut through this, okay? But we are still able to cut through this one. So that's no problem to us, as you can see. There we go. But we cannot cut through this, and that's perfect. Okay. One more thing I would like to add before we move on with the attack we want to continue is that yeah, it has to do with the range of the click detector. So you guys might have seen it earlier. So when we, for example, have an object which is up here, basically at the ceiling of this room, then you're barely able to cut it because the range is just too low, you know. So for example, okay, I'm still able to cut this one, but let's pretend that this object right here would be at the ceiling of this room. Then I wouldn't be able to, you know, cut it because the distance is just too far. So what we have to do in order to increase the range is that we have to increase the max activation distance of this click detector. So let's stop this, and max activation distance now has to become the distance from our character to the border of the room. And you guys should know what is now going to happen. So we are now going to take the size right here. Then we are going to, so we are going to take the y-axis, because the y-axis is the height of the room, and now we're going to divide it by 2. But before we do that, I just want to quickly check something. Wait, so room, where is it? OP room. So let's not take the y, but let's take the x, because the problem with y is that y is smaller than x and z. And wait, why isn't this working? $32. Wait, but why is it 32 now? Size is not a valid member of. Oh, yeah. Of course, of course not X. Wait, do we have any alternative to this one? Wait. Okay, yeah. So the problem was that we have replaced this variable with this one because we have now declared this as X. And yeah, to fix that, you just have to give this another name, you know. So that's it. So the reason why we are now using the x-axis as size and not the y-axis size is that x has a greater reach than the y, because x is greater than y, x and z are greater than y, and that's the reason why, you know. So wait, so wait, what is happening? So I am removing the room? No, okay, now it works. Wait, I was just AFK, I can't remember where I left off. Okay, yeah, okay, works fine. No. Wait, after the first cut, it does not work anymore. Why? Wait, is that because wait, it has to do with, wait, so let's call this X and let's call this room actually. So using X too much has now led to a major issue. X dot, yeah, X. This is of course room dot size. Yeah, funny thing. Now this thing is not expanding. Look at this. Room, come on. No, oh my god, come on. There we go. Okay, now it works. Now it works fine. So when I move to almost this border right here, and I'm not. Wait, but why? Because none of them has a click detector instance anymore. How funny. Wait, yeah, but wait. Why are there two? Wait. What is their distance right here? 32. Am I able to change this to something greater? Yeah, okay, I am. Okay. Okay, let's leave it as it is then. So let's work on our next move. So let's go inside of here and let me explain some things about the next move. So the fact that we are able to unequip this tool makes it a little bit more complicated for us to script this feature we want to add so that you're able to just move those parts to somewhere, okay? So that's now more difficult because once we re-equip the tool, our room is going to disappear. And yeah, that's it. So how can we get through this? So let's refer to this user input service. User input service. So let's do input begin connect function. So you guys should know about this. So this service, first of all, is responsible to receive the user's input. And when an input begins, so that means that you have pressed the key, and that's it. So this event does not know whether you have let go of the key or something else. So it only knows that you have pressed the key. Okay. The first argument we receive is input, of course, the input which you have done. The second one is GPE, which stands for game processed event, and this basically tells us whether the input was done on purpose or not, because an input is not done on purpose when you, for example, interact with in-game elements such as GUIs, chat, whatsoever, and all of this information is inside of this GPE thing. So if not, GPE means if this thing is not true, means you have done it on purpose, then we can check for the input which was done. And I'm not going to use a key and this E key, okay? So when you press E, then something certain will happen. But we of course want to add one more requirement. So if your input is E, and if there is a folder inside of the workspace called it's cut, wait, what was the name again? Yeah, there we go. So this cut parts folder, okay? Instead of having player only, we have to refer to this local player right here. So game player's local player name. So if this exists and E has been pressed, then we want to fire server with move cut parts, and then with game players local player get mouse hit P. Okay, so this might seem a little bit more difficult, but I'm gonna explain this, so do not worry. Else if what is move cut parts, then and if this folder right here exists inside of the workspace, because this folder right here is very important. So if the task is to move those cut parts, and if the folder exists, and we want to continue, then I just want to print out the position, the mouse's position, mouse pos. So print out mouse pos. Okay, let's play this again and let's see how this is going to work out now. So when I press E, nothing is happening. When I equip the tool and press E, nothing is happening either. But now when I, for example, cut. Oh my god. Yeah, okay. Instead of having wait for child, we have to use find first child. Okay, I get it. So let's redo this. So when I press E, nothing is happening. And there's still nothing happening because this folder does not exist. But when I start cutting one part and then press E, you'll see the position right here of my mouse. My mouse was pointing right here. Now my mouse is pointing right here. Now it is pointing right here. And now it is pointing right here, you know? So what we're now going to do is that when you press E, and when the position is okay, and by okay, I mean the position is inside of your room, then all of the objects are going to move towards that position, okay? So that is basically the move. Now, the check I was talking about, so how do we know when the position is okay? Means when the position is inside of the room. And that is actually pretty easy. So we just have to take this check right here, which we already have. So to check the distance in between x2, which is our origin part, so the origin part of the room, and our mouse's position. So player, character, wait for child, origin part position. Now the problem... Wait, not actually the problem. Wait, I'm not sure. Okay, yeah, so this is inside of our character. So player, character, wait for child, OP, room. There we go. So let me start cutting some parts. So position is okay, as you can see. I'm pressing E all the time and the position seems to be okay. So what happens when I move outside and start pressing E? So nothing's happening because the position is not okay, because the mouse's position is not inside of our room. But when we get back into our room and start pressing E, the position is okay, okay? So that's a check right here. So this is the same check as up here, just with the slight difference that we are now checking whether, or we're checking the mouse's position and the origin part's position's difference, and we are checking if the difference is greater than half of the length of our room. And if that's not the case, then the position is okay, because then it means that the mouse's position is actually inside of the room, okay? Because it is not longer than the room itself. So this difference right here. I hope that it is understandable, because back then for me, when I was new to magnitude, it was not understandable for me, but now I have, yeah, just acquired some knowledge, some experience, and now I'm able to understand it, you know? I hope that you guys are able to understand it as well. So, what happens when the position now is okay? So we already have some body positions inside of those cut parts. That's the good thing about it. So we do not have to create new ones. Means we can just loop through this folder right here. Come on. And we can even do get descendants. So as you guys know, get descendants gets literally everything inside of that folder. So not only those instances right here, so not only this, but also everything which is inside of that, and everything which is inside of those things. Okay. So, and why do we do that? Because we want to check if the instance we're currently at is a body position. So my idea before was that we just normally, casually just do get children, and then just do v, and then v dot body position means we are referring to the body position manually, but we can now just perform this get descendant and then just easily check if the instance we're currently at is a body position. And if that is the case, then we want to change the body position's position to the mouse position, and this is it. Now those objects will start moving towards the position you have selected. Okay, they do not, and do you know why? Because there is this tween right here which is interrupting that. Yeah, so the tween is interrupting this. Okay, so how can we stop this tween? What we have to do is that we have to use get children instead of get descendants. Okay, that's the first thing. And then we have to find first child of class, body position, come on. And then we have to destroy that body position inside of here, because otherwise you're not able to stop the tween otherwise, because we are in a totally different place right here, okay? So we are not able to refer to the tween somehow. That's the reason why we have to destroy the body position and then recreate it. So let's take this, and instead of cut part, we're going to do V, and the position is just going to be the mouse's position, okay? So those are some more lines, but those will do the work as well, so should be fine, I guess. Yeah, there we go. As you can see, this has now worked. Let's try this out again. And then I'm gonna do some stuff which is responsible to delete everything. So And by everything, I mean all of those parts which are flying around once your room dissolves, you know, because that's also a problem which we have to, you know, take care of. So let me cut some more. Let me do this position right here. And okay, somehow it did only do this to those. Yeah, the problem is that we have too much cut parts inside of here. Yeah, but why? So if we want this to not happen, then we can check if there is any folder inside of the workspace called cut parts whatsoever. And if that's... Wait, and if that's not the case, then we want to create a folder called that, you know. So that's the way to do it. Okay, so let's test this out once again. So one more problem we have now taken care of. So as you can see, there is only one folder. And there will only be one folder now. There we go. So let's cut all of them down, and there we go. All right. Okay, yeah. So now they're moving to the desired position. And after that, so we want to wait some time. Let's wait 3 seconds maybe. Well, let's add another spawn function for this. So bad practice again, I'm sorry for that. Let's do math random actually, so now we have some little variation to it. So after a random amount of seconds, from 3 to 6, we want the body position to be destroyed, and we want V to be can collide true. And then we want to add a tween to it, which does the following. So this tween is going to increase the transparency. So transparency, is going to increase it to 1, and that's going to be in 5 seconds. And once this tween is completed, we want to destroy everything. So, and by everything I mean this part, or all of those parts. So that's one way on how we are going to get rid of those cut parts, you know? So by using them, obviously. Another way, later on, is going to be by dissolving the room. I'm going to show that as well, so do not worry. What happens right here? So why isn't this working? Ah, yeah, because... because, there were some other arguments which prevented that from happening. Let's try this out again. Okay, now those parts are gone. Yeah, and after that, we want to destroy the room then. No, this folder then. Or let's not destroy it, but or at least not now. Let's focus on making this happen once the room dissolves. So the room dissolves right here, okay? So that's one spot where it dissolves. And when this happens, then we want to take this. We want to put this right here. And let's change this to something unique. Because I fear that, you know, that we're going to have some reference issues later on. Okay, so what happens right here is that we are still looping through that folder. And after that, you know, so we are checking for a body position. If it exists, then we are destroying it. And we are just, yeah, doing all of the other things as well. So can collide is turned on. This transparency effect kicks in, and then the part is being destroyed later on. So let's test this out as well. So let's cut some right here. And let's walk out of the room now, because that code was responsible for dissolving the room when you walk outside of it. And as you can see, this happens. And it looks very, very cool, so I'm proud of myself. Yeah, good thing, right? Yeah, okay. Now, the next dissolving right here, so this next possibility is right here. So when you just unequip the tool, no, when you re-equip it, I'm sorry. So when you re-equip it, then you can just take that code and then just paste it inside of here, and it will work as well, you know. So let's cut some. Okay, now let me re-equip. There we go. Okay. Now, last thing I want to do is that I want to add some effects when those parts hit something, and then I want to also deal damage to everyone which is nearby. Okay. So first of all, what we're going to do is that we are going to put a local script inside of the starter GUI, and we're going to call it cam shaker. Okay, so it is very important that this cam shaker local script is inside of every player. Okay, so keep it inside of the starter GUI if you want to. Just make sure that it is inside of every player, even inside of the attacker's starter GUI. Okay, so make sure that this is the case. Wait. Now, apart from that, create a remote event inside of the replicated storage, and also call this cam shaker. So now, game get service replicated storage, wait for child, cam shaker on client event connect function. So when a fire client, no, yes, when a fire client was performed on this remote event, we want to react to it. And what describes the task? So it is the same thing with fire server, but just the other way around. Now we are fire serving, in quotation marks, of course, from server to client, and that's called fire client. And the arguments which we are later going to add with fire clienting, so you're going to see them, is the player we want to fire client, and yeah, just any other argument you can add to it. And of course, I'm going to make use of this method right here, which is adding the argument which describes the script what to do inside of that function. So fire client, fire server. So I hope that is understandable. So if what is shake camera, then so if that is the case, then we want to take a look inside of one of my models, because I have added a camera shaker somewhere. Yeah, right here, for example. Let's take this, let's put it inside of here. And let's replace char with game, players, local player. No, wait, so let's easily replace this with this. So this right here refers to the character. So every character model is stored inside of the workspace. It has the same name as our player. Therefore, we can just refer to the workspace and furthermore refer to an instance which has the same name as our player, and then we can make sure that this has to be our character. Now, cam, of course, is our camera, so our camera sits inside of the workspace, so workspace.currentCamera should do. Okay, so this camera shaker right here stores the former offset of your humanoid, so the camera offset, and then it begins to manipulate the camera offset. Not only the camera offset, so also the field of view, for example, and after a certain amount of time, everything is just being reverted, okay? So nothing too serious right here. Okay, let's go inside of the script. And inside of here, inside of this move cut parts place right here, we want to refer to this camera shaker thing, and we want a fire client, and only for our player. The camera was shake camera, shake camera. So that's a task, and this only goes for our player. So fire client, as I've told you, first argument is the player you're fire clienting to, and the second argument can be anything you want. In this case, it is going to be the task right here. Okay, so I think that I've explained this already. So let's take this and let's continue with dealing damage. So how is this going to work? We're going to do something similar to this thing. So we are looping through the workspace. To be honest, we are using getDescendant, so you guys should know what getDescendant does. Instead of looking for something which is a part or a union operation, we are looking for something which is a model, not a character model, a model, okay? So if the thing we are now at is a model and has a humanoid, and does not have the same name as our player, means it's not our character's character, is not our player's character, then we want to continue. Then we first of all just want to deal damage to this thing. Wait, oh my god, I've messed up. Yeah, then we just want to deal damage to this thing. So take damage, because so judging by this, what we have right here, this could be a character model of a player, but also a character model of an NPC, for example, okay? So to clarify whether this is a player or not, we can just do if game.players find first child v.name, then. And let's use something else instead of v. Let's use v2. There we go. So we are basically looking for a player instead of that players tab, which has the same name as this character model. And if something exists, then we can make sure that this character model we are now referring to, or we have referred to, it belongs to this player, which we are now referring to down here. Alright, so that's in how to do this. And you might ask, okay, so why is it important to know whether this is a player or not? And the reason for this is because we want to do this camera shake of thing on it. And there is no point in doing it to an NPC, so the NPC doesn't care if its camera is shaking or not. I even doubt that the NPC has a camera or a perception itself. So we only want to perform this on real players. And instead of having player right here, you have to have this, okay, because this refers to the character model's player. And that's it. Yeah, so we are now dealing damage, having this camera shaker effect. That's it. Okay. Thank you guys for watching. Leave a like, subscribe, share this video to all of your friends, leave me feedback in the comment section, guys. Take care and see you in the next video.